Welcome to the study of chemical reactions part 3. Here we will discuss about the two theories, collision theory and transition state theory. In collision theory, this theory proposes that the process of intermolecular collision is responsible for a reaction to take place. Therefore, primarily the reaction rate of a chemical conversion can be accounted for by knowing the frequency of collisions of reactant molecules, which in turn depend on molecular concentration and molecular motion, which is temperature dependent. Collision between the molecules becomes significantly fruitful due to presence of molecules carrying at least a minimum amount of energy, termed as energy of activation. It acts as an energy barrier called activated complex, through which the reactant molecules pass during their conversion to the product molecules. Now, the transition state theory. This is an alternative but more useful approach for understanding a chemical conversion is under transition state theory. According to this theory, reactant molecules undergo change in their energy states during the reaction through their approach to each other and thus ready to collapse into the product molecules. This theory proposes the view of free energy of activation, delta G hash. As higher it is, lower is the reaction rate. As the height of energy barrier through which reactant molecules pass as being converted to active species called transition state or activated complex before leading to the product molecules. Consider the equation delta G hash is equal to delta H hash minus T into delta S hash is equal to minus 2.303 RT log K hash. If we consider the energy profile diagram, consider this reaction where nucleophile attacks and this is the activated complex or the transition state and finally it collapses to the products. You can see the energy profile diagram. This is the transition state and this is called free energy of activation, and this is the free energy change from going to the reactants to the products. Now, on the viewpoint of above discussion, conclusive remarks on the reaction rate, free energy of activation and the standard free energy difference of a chemical conversion may be as standard free energy difference delta G0 between the reactants and the products is a thermodynamic quantity and hence it does not influence the reaction rate. Height of the energy barrier represented by delta G hash as the free energy of activation, as you have seen in the energy profile diagram previous slide. In reality, the vital dependable factor for the rate of a reaction. Greater the free energy of activation is, slower the rate of a reaction. Now consider the two energy profile diagrams. Now, what is the kinetic of reactions and the rate limiting step? The aim of kinetic studies of chemical reaction is to know of how fast the starting materials are converted to products. Kinetic study of reaction completes with establishing the relation between measured reaction rate and concentration of the reactants. In the first energy profile diagram, this one, it discloses that the reactants are being transformed via the transition state 1 to the intermediate, this is the intermediate, which finally collapses to the products via the transition state 2, this one. From the diagram, it is also clear that formation of intermediate from reactants via transition state 1 demands more free energy. It demands more free energy of activation, more free energy of activation than that of collapsing the intermediate to the products via transition state 2. That is, delta G1 hash is greater than delta G2 hash. That is, step 1 is slower because it needs more energy of activation, free energy of activation. So step 1 is slower of the two, and it is the rate limiting step. In the second case, the energy diagram indicates that the formation of intermediate from reactants via transition state 1 demands less free energy of activation than that of collapsing of intermediate to the products via transition state 2. That is, it is lower in energy and it is higher energy. That is, delta G1 hash is less than delta G2 hash. Therefore, step 2, that is conversion of intermediate to products, is slower of the two, and it is the rate limiting step. We will further discuss about the transition state and Hammond's postulate in our next video. Thank you.